Today's lesson is solving for the molar mass of a sample using the ideal gas law. At first, this might seem impossible because there is no mass in the ideal gas law. There's pressure, volume, moles, the gas constant, and temperature. But if you really think about it, moles is actually just mass divided by the molar mass. So we can use n if we figure it out, and a mass if we're given it from the problem, to calculate this molar mass. Let's do a couple problems to try to work through this. All right, first one, solve for the molar mass of a 10-gram sample of a gas held in a 15-liter container at a pressure of 1 atmosphere and a temperature of 0 degrees Celsius. So, first our equation is this, PV equals nRT, and we're going to set it up to solve for n. So in this case, n equals PV divided by RT. We're going to plug this in, P, 1 atmosphere, V, 15 liters. R has to be 0.082 because P is in atmospheres. And finally, 0 degrees Celsius for my temperature, but before I can plug it into my equation, I have to convert to Kelvin. To convert to Kelvin from Celsius, add 273. When I solve this problem, I'm going to get 0.67 moles. Now, this is only the first half of the problem. We're going to plug in 0.67 moles is equal to the 10 grams that we started with divided by the molar mass, which we don't know. Now, we can rearrange this so that x equals 10 divided by 0.67, and that equals 14.9 grams per mole. Let's do one more problem. Let's see if you can work through it a little bit on your own. Let's say you have a 37-gram sample of gas that's held in a 4-liter container at 100 degrees Celsius and 15,000 torr. Just like in the last problem, we have to solve for n first. And why don't you try to plug in my missing variables? If you've done this correctly, you should plug in 15,000 times 4 divided by R, which has to be, in this case, 62.36. The reason is because pressure is in torr. Now for temperature, we're not going to plug in 100. We have to convert to Kelvin first, so 373. If you solve for this, you're going to get an answer of 2.58 moles. Again, this is just the first half of the problem. This is a necessary step, but it is not the answer. See if you can figure out what the answer is now. That's right. We're going to use this equation here. 2.58 moles is equivalent to this 37 grams that we started with divided by whatever the molar mass is, which we don't know. If we rearrange this equation to get x by itself, we're going to get x equals 37 divided by 2.58, and your answer 14.3 grams per mole. Okay, these types of problems require an additional step, right? This step here, right? But they are fundamentally the same as any other ideal gas law problem. Good luck.